Good morning, friends. This is the video on fragility analysis. Fragility is the probability of accidents of some damaged limit state when some earthquake force is acting on a structure. So this gives you a pictorial view of how much is the probability of accidents of a certain kind of damage. So today in this video we shall be discussing the theoretical background of fragility curves, steps to develop the curves. However, the actual numerical application and the drawing of the curves we shall take up in the next video. So this is part 2 of fragility chapter. Here we are discussing the theoretical background of the fragility curve. So let us have a definition of this. A fragility function is a mathematical function that expresses the probability that some undesirable event occurs. Typically, a component reaches or exceeds some clearly defined limit state. As a function of some measure of environmental excitation, typically a measure of acceleration, deformation, or force in an earthquake, hurricane, or other extreme loading condition. So, a definition, a still shorter definition is like this: a fragility function or fragility curve gives a conditional probability that a structure reaches or exceeds a specified damage state under an intensity measure of ground motion. What is the intensity measure, etc., we shall see in the coming slides. Fragility analysis estimates the probability that a structure reaches or exceeds a certain damage state for a given level of earthquake intensity. So there is a mathematical expression for fragility as given here. Fragility equal to probability of a damage state exceeding some damage limit state. So damage state can be a function of demand. So we are writing in terms of demand here. So it is in a broad sense, but fragility is the probability of any demand exceeding the capacity under some intensity measure. IM is the intensity measure. So here D is demand, C is capacity limit state, IM is the intensity measure. So let us see what are the demands that is imposed by the earthquake. It can be force demand, it can be displacement demand, it can be strain demand, it can be ductility demand, it can be drift demand. Similarly, capacity has different facets, different types of capacities: flexural capacity, shear capacity, torsional capacity, combined action capacity, displacement capacity, drift capacity, and so on. Mathematically, fragility can also be expressed as like this: fragility equal to probability of some damage state, DS is a damage state, of exceeding certain damage limit state under some given intensity measure. So mathematically it is expressed as phi of ln Im minus lm alpha divided by sigma. Phi is actually the standard normal cumulative distribution function. CDF means cumulative distribution function. So log A minus log B equal to log A by B. So I can also write it like this: log ln Im by alpha, where alpha is the mean value of the intensity measured data and sigma is the dispersion or standard deviation of the intensity measured data. So this is the mathematical expression. Now intensity measure, let us try to understand and see its different types. Intensity measure is a scalar parameter that quantifies the severity of earthquake ground motion at a site. So it can be expressed in under different facets. So one is the peak ground acceleration, PGA. It is simple, understandable, but not good parameter for flexible structures and drift controlled structures. Tall structures are flexible, so their PGA as an intensity measure may not be suitable. Peak ground velocity, it has better correlation with damage. Peak ground displacement, it is good for long period structures. As we have seen, the peak ground acceleration was not good for tall structures which are flexible. So peak ground displacement may be good fit as intensity measure for those structures. Then you can also have spectral acceleration, widely used, spectral velocity, less common, and spectral displacement, much used in displacement based design. So spectral acceleration, spectral velocity, and spectral displacement are also intensity measures. Other intensity measures are energy based, like earthquake imparts energy to structures, so that energy can be considered as intensity measure. Duration based, duration of the ground motion. Frequency content based, a mean period, predominant period, Fourier spectrum based, and vector valute like SAT1, duration, etc. So this is also popular. So we are revisiting the types of the intensity measures. Amplitude based PGA, PGB, PGD. Codal design and quick checks are possible with this. Spectral parameter based, like based on SA, SB, SD. It is used in PBSD and fragility analysis. It can be energy based, areas intensity, cumulative absolute velocity, etc. It is used in damage and soil fracture. Duration based, like D5 and D95. 5% of the duration, 95% of the duration. So it is used in cumulative damage calculation. Frequency based intensity measure, mean and predominant period, used in resonance studies. Vector based, like SAT1 plus duration, for historical assessment. Now let us see another parameter used in the fragility, which is called engineering demand parameter, EDP. Definition is like this: an EDP quantifies the structural response or demand caused by earthquake ground motion. So IM we have seen, it signifies how strong the earthquake is. EDP signifies how the structure responds to the earthquakes. So it will depend on its health, it depends on its design, it depends on its amount of steel, the quality of material, and so on. Damage measure, DM, damage measure signifies what damages occurs. A loss, structural, non-structural, and downtime loss. So ultimately, everything will be converted to the loss. Types of EDP are like this. Deformation based, mostly used, like interstory drift ratio, roof drift, roof displacement divided by total height is called the roof drift. Then plastic rotation, peak displacement. And these are used correspondingly in fragility curves, building behavior, global performance checks. Plastic rotation is highly used in PBSD. Peak displacement is used in long period structure, tanks, silos. Force based, like base shear, used in preliminary design, capacity check, member forces, Codal design, not so strong. Acceleration based, peak floor acceleration, PFA, for equipment design resting on the floor. Flow response spectra for equipment design resting on the floor. Velocity based, peak floor velocity, PFV, as used in dampers, sensitive equipment design, etc. Velocity based again can be peak floor velocity, PFB, dampers, sensitive equipment design, etc. Energy based, static energy, low cycle fatigue, energy based analysis. Acceleration based, EDP, peak floor acceleration, PFA, used in equipment design, flow response spectra used in equipment design. Velocity based, peak floor velocity, PFB, dampers, sensitive equipment design. Damage index based, like Park and Yang, etc., damage studies used. Now, what kind of IM, intensity meter, and EDP can be combined together to make the fragility analysis? For buildings, intensity measure is SAT1, spectral acceleration at first fundamental period, and versus the EDP as maximum IDR, interstory drift ratio. Then in bridges it can be SAT1 or PGB, and EDP is column drift. For tank silos, intensity measure SAT1 or SDT1, and EDP shell displacement. For non-structural components, intensity measure PGA or PFA, and EDP is floor acceleration. Practical computation is like this. Fragility equal to probability of accidents of a damage state greater than or equal to a given damage limit state with the intensity measure given as x. So it can be expressed as phi, that is the CDF function, x by alpha divided by sigma. X is some value of the intensity measure, alpha is the mean of the intensity measure, and sigma is the dispersion of the intensity measure values. This probability of damage state exceeding a limit state under intensity measure x. Phi is called standard CDF, cumulative distribution function. Alpha is mean natural logarithm of IM, Sigma is logarithmic standard deviation representing total uncertainty. Alpha is given by this formula of statistics and sigma is given by this formula of statistics. N is the total number of ground motion records, that is total number of intensity measures considered. And this expression is nothing but the value of Z given in the probability books. So Z tables are available giving the area or ordinate of the probability density function. So this Z can be calculated from here, and utilizing the table you can get the corresponding probability. So a practical computation can be select the intensity measure PGA, EDP, say IDR, select earthquakes as per FEMA P695. This let us see here. So FEMA P695 has given tables for summary of earthquake event and recording station data for far field record set. Similarly, other table is there for near field record set. Each set consists of 22 ground motions. So these are already set like Northridge to up to Friuli, Italy, and Loma Prieta, Kobe, etc. in between. And Imperial Valley also is there. There are years of occurrence and their peak magnitude. Magnitude is given, and the name and who obtained the data, those are available. So you have to use these 22 records to produce your fragility curves. These 22 records will not be used directly, but you have to find out the SCGM, the spectrum computable ground motion corresponding to this background earthquakes. Then third step is generate SCGMs corresponding to the earthquakes as in step 2, as I have said. Then fourth is carry out incremental dynamic analysis IDA, find the EDP values corresponding to the damage states, compute probabilities of accidents as we have discussed, calculate Z, then from the table we find the probability. A simple fragility curve will be looking like this. For some damage state, one curve, another damage state, another curve, and so on. We have taken 3 damage states here depending on the peak value of the interstory drift ratio, 1.5%, 2%, 3%, and 4%. 4% is supposed to be the collapse level. So these correspond generally to immediate occupancy, life safety, intermediate, near, and this is collapse. So how to generate these curves and what are the other mathematical backgrounds, that numerical example we shall take up in the next video. So thank you very much for coming with me up to here. If you find the video useful and informative, please subscribe the channel. Please like and share the videos and put your comments and queries in the comment box. I shall be glad to answer those. Thank you.